Okay, in this presentation we are going to look at definite integrals. Now, in particular what we're going to do is use integration by substitution in this particular example. So here's our expression here. The limit from 0 to the square root of 3 of x divided by the square root of x squared plus 1 dx. Now, essentially the reason we're going to use integration by substitution is this term here is a bit awkward to deal with. So what we have to do from the entire expression here is to choose a term that we can use represent with just one symbol, which we're going to call u. Now, for ease of use, something that is relatively easy to work with, so we're going to pick x squared plus 1, an expression that has a very high power. For example, here x to the power of 2 plus 1, that expression there would be very appropriate. So x squared plus 1, so we're going to let u is x squared plus 1. First off, what we're going to do is differentiate both sides. So du dx equals x squared plus 1. What I'm going to do now, or sorry, it's not, it's actually 2x, silly me. What I'm going to do now is multiply both sides by dx. So we have du equals 2x dx. Now, I'll just draw your attention to this here. The expression here contains the term x times dx. So that those are actually can be considered two parts of a product. And so what we're going to do here is we're going to go one step further and go divide both sides by 2. So we have x dx. So now we'll just disregard the limits for the time being. So we can re-express the whole thing there as something over the square root of u x dx. So that is 1/2 times du. The square root of u, 1 over the square root of u is 1. It can be written as u to the power of minus 1/2. Okay. So just to emphasize one more thing, square root of u can also be written as u to the power of 1/2. So this expression here is far simpler to work with. So we're going to be able to work with this expression here. Now I'm just going to move on to the next few slides here because I sort of don't want to cram everything onto one side. So that is essentially, in a nutshell, you can pause it there. That is just everything I've written in the last slide, just a bit clearer to look at. So moving on. This is where we were at now. So we have, this is where I sort of finished off in the previous slide. So this is where I'm going to pick things up again. So the integral of u to the power of minus 1/2. Well, essentially what we're going to do is this term. This is like the key thing here. So we're going to add 1 to that value, plus 1. So minus 1/2 plus 1, and that gives us u to the power of 1/2. And we're also going to divide by that. Now, we're going to bring in the 1/2 here. Okay. And also what we are going to do is bring in the coefficient of integration. Now, for the sake of being correct, we're not going to really look at the limits just yet. We're going to wait a while until we come back to those. We can multiply these two terms here. So this is a 2 times 1/2. That just becomes 1. So everything really sort of cancels out there. So 2 times 1/2 is 1. 1 divided by 1 just cancels out. So we're left with essentially the square root of u plus c. So moving on to the next slide. Again, this is where I have square root of u plus c. Okay. I've sort of really gone quite far there. Now, essentially what I want to do is to recall that earlier on, we're going to sort of go back to dealing with x. We're going to stop using u now. So u was x squared plus 1. So this expression here can be written as follows, because this expression up here is directly equivalent to this down here. So this expression here is directly equivalent to this expression here, although it would help if I put in the coefficient there, just to integration there, just to be absolutely crystal clear. So this is essentially the answer to the integration part of the problem. We just have to put in the evaluate it for the limits now, just to finalize the problem. So the limits are the square root of 3 and 0. So what we're going to do is evaluate it for the square root of 3. So the square root of 3 squared plus 1, and we're going to subtract the evaluation for the lower limit, and that is 0 squared plus 1. That is essentially that just all works out to be 1. 0 squared is just 0 plus 1, so the whole thing just evaluates to square root of 1, which is 1. Okay, the square root of 3 squared is 3 plus 1, square root of that is square root of 4, and that is 2. So this works out to be 2. So essentially the answer is 2 minus 1, and therefore the answer is 1. So let's look at that now on the next slide. There I have it done there. So again, this is square root of 3 squared, and this is 0 squared. And evaluate it for the upper limit and the lower limit. 2 minus 1, and that is equal to 1.